Hey guys, it's LJ with HEARTSTART and today we're talking about medication calculations using the universal formula. The universal formula is a basic formula that can expand to incorporate any medication administration by adding or subtracting variables. It can be used to calculate a single dose and volume of any medication. It can be used to calculate the administration of weight-based medication orders. It can be used to calculate the administration of medication ordered in minutes, and it can be used to calculate the administration of medication ordered over an hour. When we set our universal formula up, it looks like this. It's our desired dose multiplied by our weight in kilograms, multiplied by our time coefficient, which will always be 60, multiplied by our volume in milliliters, and we'll divide all of that by our supplied amount. When we calculate that, that will give us our dose measured in milliliters, or if it also includes our time-based component, it will give us our dose in milliliters per hour. The great part about the universal formula is we only need to use the parts of it that we actually need. If you don't need a certain variable, don't use it. So we need to ask ourselves, what's our desired dose? Is this a weight-based order? And if it is, it's measured in kilograms. If it's not, leave it out. Is this a time-based order? If it is a time-based order, our time coefficient is always 60. What's the volume measured in milliliters of the medication? And finally, how is the medication supplied? Is it supplied in grams, milligrams, micrograms, or units? We always have to have at least the following things. It's going to be our desired dose, our volume in milliliters, and our supplied amount, which is again measured in grams, milligrams, micrograms, or units. Let's look at our supplied medications. So one of the things we also have to do is determine the supplied amount on hand, and whether that's in grams, milligrams, micrograms, and units. We'll look at this vial of fentanyl and we'll see that the supplied amount is 250 micrograms. We next have to determine the volume in which the medication is supplied. So it's supplied in 5 milliliters. That's our volume. So it's 250 micrograms supplied in 5 milliliters. The universal formula determines how much volume, how many milliliters, it would take to achieve our desired dose. So we have some other rules. Our desired dose and the supplied amount must always be measured in the same units. So we may have to convert. So there's something called the factor of 1,000. And you can see that we have 1 gram and we need to put it into milligrams. So there are 1,000 milligrams in a gram. So what we'll do is we'll take our 1 gram and we'll add 3 zeros behind it to convert it to milligrams. Likewise, if we're stepping up, we have 1,000 milligrams. We want to convert that back to grams. We'll just take those 3 zeros out and then we'll step up to grams. You'll see that 1 milligram equals 1,000 micrograms. So what we'll do is we'll take a milligram, and if we need to convert it to micrograms, we'll just add 3 zeros behind it, and then we get our micrograms. Likewise, if we have 1,000 micrograms and we want to convert that up to milligrams, we'll just take those 3 zeros out, and then there we go. That's what we have in milligrams. So one more example, we have 7 grams. We'll convert that to milligrams. We'll just add 3 zeros behind that 7, and we'll get 7,000 milligrams. And likewise, we have 700 milligrams, and we'll convert that to micrograms. And so we'll just take and add 3 zeros behind it, and now we have 700,000 micrograms equals 700 milligrams. So we have to get our desired dose and our supplied amount in the same units of measurement. For this example, we have 1,500 milligrams for our desired dose, and it's supplied in 2 grams. We'll set our formula up, and you can see we have 1,500 milligrams for our desired dose, and we converted our grams to milligrams by simply adding 3 zeros behind it. Let's look at that one more time. So this time, our desired dose is 20 micrograms, but our supplied amount is in 5 milligrams. we need to convert the 5 milligrams to micrograms. So when we set our formula up, you see for our desired dose, we have 20 micrograms. And then our supplied amount, we converted that also to micrograms from milligrams. We just took that 5, we added 3 zeros behind it, and now we have 5,000 micrograms to make sure that our desired dose and our supplied amount is in the same units of measurement. So weight is also a variable, but it's always calculated in kilograms. 1 kilogram equals 2.2 pounds. So if we have 220 pounds, we'll divide 220 by 2.2, and when we calculate that, you'll see we get 100 kilograms. This time we have 40 pounds, we'll divide that by 2.2, and you can see we come up with 18.2 kilograms. And then if we have 10 pounds and we divide that by 2.2, you'll see that we get 4.5 kilograms. Time is also a variable. If the medication is ordered in minutes, the known variable is 60. This is what gives us our milliliters per hour. If you're a pre-hospital provider, any medication you're giving ordered in minutes should be given on a 60 drop set. The drops per minute will also be the same as your milliliters per hour. If a medication is ordered over a certain number of minutes or a different drop set than a 60 drop set, if you're hanging your medication to gravity, use a guide, application, or drip rate equation. When we set our formula up, you can see that we put in time here for our time variable, and it's always 60. Volume is the amount of solution in milliliters that the medication is supplied in. For example, we have 1 milligram of epinephrine supplied in 1 milliliter. We'll set our formula up, and you can see this is the place that we would insert our volume. And so right here we put 1 milliliter because we have 1 milliliter of epinephrine. So let's look at some practice problems. We have an adult patient that's experiencing an active seizure. An IV has already been established, and our dose of midazolam is 2.5 milligrams. Our midazolam is supplied 10 milligrams in 2 milliliters. There's no weight and there's no time in our order, therefore this is an IV push. We'll set our formula up, and you can see we have 2.5 milligrams for our desired dose. There's no weight, so we'll leave it out. There's no time component, so we'll leave it out. We'll multiply that by our volume, which is 2 milliliters, and we'll divide that by our supplied amount, which is 10 milligrams. When we calculate that, you'll see we'll give 0.5 milliliters of midazolam to make sure that our patient gets the 2.5 milligrams that was ordered. This time we have a 24-pound patient that presents with an allergic reaction. An IV has already been established, and we're going to give diphenhydramine this time, and the dose is 2 milligrams per kilogram. The diphenhydramine is supplied 50 milligrams in 1 milliliter. There's no time indication, therefore this is an IV push. And when we set our formula up, you'll see that we need to put 2 milligrams for our desired dose. We'll multiply that by our weight in kigs. So we'll convert 24 pounds, divide that by 2.2, and we get 11. We'll leave our time variable out. We'll multiply all of that by our volume, which is 1 milliliter that our diphenhydramine is supplied in. And our supplied amount for diphenhydramine is 50 milligrams. When we calculate that, you'll see that our volume, to make sure that our patient gets the correct amount of diphenhydramine, is 0.44 milliliters, and that our total desired dose, once we multiply our desired dose by our weight, is 22 milligrams. This time we have an adult patient who's hypotensive after some normal saline and is experiencing suspected septic shock. Our order is to give norepinephrine at 10 mics per minute. Our norepinephrine is applied 4 milligrams in 1,000 milliliters. This is an infusion since it's given over time. We'll set our formula up, and you can see that we have 10 micrograms for our desired dose. There's no weight component this time, so we'll leave it out. We'll multiply that by our time coefficient, which is 60. We'll multiply that by our volume, which is 1,000 milliliters, and we'll divide that by our supplied amount, which is 4 milligrams, but we converted that to micrograms by adding 3 zeros behind it to get our desired dose, which is in micrograms, and our supplied amount in the same units. And we'll calculate that, and you'll see that we'll put it up on our pump at 150 milliliters per hour. If you're a pre-hospital practitioner, then you'll see if you put that on a 60 drop set, you'll run that out at 150 drops per minute. For our last problem, we have an adult patient that's hypotensive post-cardiac arrest. We have IV access and our patient weighs 250 pounds. We have an order for dopamine at 10 mics per kg per minute, and our dopamine is supplied in 400 milligrams in 250 milliliters. We'll set our formula up, and you can see we have 10 micrograms for our desired dose. We'll multiply that by the patient's weight in kilograms, which is 114. We'll also multiply that by our time coefficient, which is 60, and then by our volume, which is 250 milliliters. We'll divide all of that by our supplied amount, which is 400,000 micrograms, which was converted from milligrams by adding 3 zeros behind it. When we calculate that, we get 42.75 milliliters per hour. Because pumps usually run to the nearest tenth, we'll round up to 42.80 milliliters. And if we're hanging this to gravity in a pre-hospital environment on a 60 drop set, we'll round up to 43 drops per minute. Guys, thanks for tuning in. We hope you learned something. Please see the show notes and visit HEARTSTARTNOLA.com for HEARTSTART NOLA reference cards, guidebooks, and other great stuff to help you with your pre-hospital, emergency, and critical care needs. This is LJ with HEARTSTARTNOLA.com saying, see you next time.